Question 7. Cones is a sculpture in the National Gallery of Australia. It consists of 14 identical steel cones, arranged into pairs which are joined together as shown. The height of each cone is equal to the diameter of its base. If the radius of the base is 2.25 meters, write the height of a cone. Well, we're told that the height is equal to the diameter. The diameter of a circle is 2 times the radius of the circle. We're told that the radius is 2.25 meters. So let's sub that in for the radius. And the calculation here, 2 times 2.25 comes out as 4.5. Our unit here is meters, so our final answer is that the height is 4.5 meters. Part II. Show that, correct to 2 decimal places, the slant height L of a cone is 5.03 meters. The following fact will be quite helpful. If a cone has a radius of r, a height of h, and a slant height of L, then L squared is equal to r squared plus h squared. This is a good fact to know, but if you didn't know it, it could be derived on the spot by using Pythagoras' theorem. From part I of the question, we know that our cone has a radius, r, of 2.25 meters and a height, h, of 4.5 meters. Let's sub these into our result. From here, we can simplify the right-hand side by doing some calculator work. We found that L squared is equal to 25.3125. To find L, we'll need to remove the square. The inverse of a square is a square root, so to remove a square, we should take the square root of both sides of the equation. From here, it's a matter of doing some calculator work and some rounding. Rounded to 2 decimal places, L is equal to 5.03. L represents the slant height, and the unit here is meters. So our final answer is that the slant height is 5.03 meters. This is exactly what we were asked to show. Part B. In order to maintain the steel's reflective shine, the surface is polished regularly. Find the curved surface area of the entire sculpture, 14 cones. Give your answer correct to 2 decimal places. The shape we're concerned with here is a cone, and we are asked about the curved surface area. There's a result on page 10 of the formula book which will help us here. It says that the curved surface area, A, of a cone with radius r and slant height l is A is equal to pi r l. From the previous parts of the question, we know that each individual cone has a radius r of 2.25 meters and a slant height l of 5.03 meters. To find the curved surface area of one cone, we sub these values into our formula. A is equal to pi r l. So we found that the curved surface area of one cone is 35.5550. However, the sculpture isn't just one cone, it consists of 14 cones. To find the curved surface area for 14 cones, all we have to do is multiply this number by 14. This gives an answer of 497.77. The distances in this question were measured in meters, and for an area we always need to use squared units. So our unit here is meters squared. This means that our final answer is 497.77 meters squared. Part II. 1 litre of polish will cover 12.25 meters squared. Find how many litres are needed to polish the entire sculpture. Give your answer correct to the nearest litre. Well, we're told that 1 litre of polish covers 12.25 meters squared of area. From the previous part of the question, we know that the complete area of the sculpture is 497.77 meters squared. So this is how much area that needs to be covered. To find how many litres of polish we need, we simply divide these two numbers. When we do this calculation, we get 40.6343. We were asked to give our answer correct to the nearest litre. So to get our final answer, we round this to 41 litres. Part III. A container of polish contains 5 litres and costs 110 Australian dollars. Find the number of containers of polish that must be purchased in order to polish the entire sculpture. And hence, find the cost of the polish in euros, given that 1 Australian dollar is equal to 0.68 euro. Give your answer correct to the nearest euro. From the previous part of the question, we know that we need 41 litres of polish. And we're told that each container contains 5 litres. So, how many containers will we need? Well, 8 containers would give us 5 times 8, which is 40 litres. This is not enough since we need 41 litres. 9 containers would give us 5 times 9, which is 45 litres of polish, and this is enough. So the minimum number of containers, which ensures we have enough polish, is 9 containers. Now, let's think about finding the cost of the polish in euros. We are told that one container costs 110 Australian dollars. We need 9 containers, and to find the price of this, all we have to do is multiply by 9. So 9 containers would cost 9 times 110, which is 990 Australian dollars. The question asked for the cost of polish in euros, not Australian dollars, so we'll have to do a conversion. We're told that 1 Australian dollar is 0.68 euros. To convert 990 Australian dollars to euros, we multiply both sides by 990. So we found that 990 Australian dollars is equal to 673.2 euros. We are asked to give our answer correct to the nearest euro. So to get our final answer, we round this to 673 euro. Part C. The diagram, not drawn to scale, shows the net of the outer surface of one of the cones of the sculpture. It is a sector of a circle of radius length 5.03 meters with arc length p meters and angle theta at the center, as shown below. Find p, the length of the arc of the sector. Give your answer correct to 2 decimal places. The key here is to get a good understanding of what this diagram really represents. We're told that it's the net of the outer surface of one of the cones. So let's have a think about the structure of one of the original cones. Since we're concerned with the outer surface, it will be helpful to imagine that the cone is hollow and is open on the bottom, sort of like an ice cream cone. Now, imagine we got a sharp knife and cut down a line from the tip of the cone down the side to the base. We could then flatten out the cone flat on the ground. Here, the tip of the cone corresponds to the centre of the circle, which I've coloured in blue. The cut we made with the knife corresponds to the radius of the circle, which I've coloured in green. And the circumference of the base of the cone corresponds to the arc length in the circle. I've coloured this in purple. The key takeaway from that illustration is that P, the arc length, corresponds to the circumference of the base of the original cone. We have a formula on page 8 of the formula book which allows us to find such a circumference. It says that a circle with radius r has circumference L given by L is equal to 2 pi r. we want the circumference of the base of the original cone. In part A, I, we were told that this radius is 2.25 meters. So to find our circumference, we sub in this radius to our formula. Our unit here is meters, so our final answer is that P is equal to 14.14 meters. Part II. Find theta, the angle at the centre of the sector. Show all your working out. Give your answer correct to the nearest degree. In the previous part of the question, we found that the arc length P was equal to 14.14 meters. So let's write this in. So, there's three things which are labelled in our sector: the angle, the radius, and the arc length. There is a formula on page 9 of the formula book which tells us how these quantities relate to each other. It says that the arc length, L, of a sector spanned by an angle of theta degrees in a circle of radius r is L is equal to 2 pi r times theta over 360. This equation will allow us to solve for the unknown angle theta. In our sector, the arc length L is equal to 14.14 meters. The radius r is 5.03 meters. Let's sub these values into our formula. From here, we can do some calculator work on the right hand side to simplify things a bit. 2 pi times 5.03 is 31.6044. To simplify things further, I'm going to eliminate the fraction on the right hand side. Theta over 360 means theta divided by 360. The inverse of division is multiplication, so to remove division by 360, I will multiply both sides by 360. So we found that 5090.4 is equal to 31.6044 times theta. To find theta, we'll need to remove this 31.6044 from the right hand side. This number is being multiplied by our theta. The inverse of multiplication is division, so to remove this multiplication, I need to divide both sides by 31.6044. From here, it's a matter of doing some calculator work and some rounding. Rounded to the nearest degree, our final answer is that theta is equal to 161 degrees.